Hi everyone, if you're ever into game development, you will realize that most of the time you will be stuck with hand modeling and rigging 3D objects by hand in Blender. And that's very complicated. That's why I built Git Mesh to simplify all of that. So Git Mesh is an autonomous Git native 3D access pipeline that lives in GitLab. It's very simple to use. Let me show you. All you have to do is press in the new item to create a new issue over here. And I just need to create a new issue and the pipeline can handle the rest for me. Very simple, right? So right now the webhook listener gonna catch that event payload. I just sent it and it's gonna send to Google ADK's orchestration layer behind the scene and everything is gonna be working. It usually take 8 minutes, so I will be back. And we are back. So the life cycle seems to be completed. It closed itself 5 minutes ago and created like 12 minutes ago, so it ran for like 7 to 8 minutes. That's not too bad. And let's have a look closer in the details. So you can see these are like the logs of what happened when it runs. So there are like 10 stages in overall. So each of these is gonna tell you what happened in each stage, and in the end, you can find 2 links to see like a turntable preview of the object itself. The other one is like the download ready, version ready animated GLB for you. Just click the link and it's gonna download for you. Pretty simple, right? Now that you know how the flow runs, let's have a deeper technical look at how it works. So first, when the user creates a GitLab issue with this format, meshgen, and then your object, it's gonna find an issue into the model webhook listener and send a trigger CI pipeline via token. Using this YAML, it's gonna run the model app.py. And here's the main orchestration works. So at stage 2, it's gonna send the text into an image using some Gemini Vertex AI models. I think we're using Imagen over here to create a reference image, so like text to image. And then at stage 3, we create some 3D mesh using Trellis 2, deploy on the L4 GPU. And over here, we have some validation on the GLB that we created to make sure it's valid. Stage 4, we use some Gemini to guide it to cut like segmentation of the GLB object that we just had. Stage 7, we start to label that segmented parts. As the next stage, to see where we plan how should the animation looks like for those parts. At stage 9, we're going to validate that again, and stage 10 is the final animation and rendering using Blender headless container, and that's going to upload the GLB in MP4 back to GitLab, issue comments, and then it's going to close the flow after it's done.